Hey guys! So today we are going to start our astronomy unit. Okay, and this is the first assignment for the beginning of the second semester of the year. Can you believe we're already here? Too crazy. Now, just a reminder, if you're watching this for the first time, please make sure you are watching this video in Edpuzzle. Every single time I have people who just start on YouTube and then they have to go back and watch it again in Edpuzzle. Please watch the video in Edpuzzle. Okay, let's get started. So we are starting astronomy. And we are going to be learning about the Earth, the Moon, and the Sun. And these are the first things that we're going to be talking about, okay? Is the Earth and the Moon and the Sun. Now, the Earth and the Moon and the Sun have a very tight relationship, and they affect each other a lot. Without the Sun, there would be no solar system at all, and there would be no Earth, and there would be no Moon. And so the Sun is very important, and all life on our planet comes from the Sun, and the actual existence of the Earth comes from the Sun. Okay? Now, the Earth and the Moon and the Sun all have a relationship, but the Moon is what controls the tides on Earth. Do you know what it is? That is a scientific phenomena that connects the tides on Earth and the Moon? It's gravity, right? And so the gravity of the Moon, as it goes around the Earth, pulls the water into different types of tides. Okay. One thing that people have a really hard time with when we talk about the solar system and the universe and everything is that they have a hard time thinking about the actual magnitude of the size of things. Okay? The diameter of the Sun, you could line up 100 Earths and then it would equal how wide the Sun is. 100 Earths. And the Moon and the Earth have a similar relationship. 4 moons to go across the diameter of the Earth. So the Sun is huge. And believe it or not, the Sun is actually not a big sun in proportion to other stars in the universe. Our star, our Sun, is about an average middle of the road color and an average and a middle of the road size for a sun. It's not a small star and it's not a big star. It's a definite middle in the middle. Okay? So when we talk about the relationship with the Earth, the Sun, and the Moon, we need to learn some fundamental things. Okay? We know that all our planets go in a circle. They're constantly turning. On Earth, we're constantly turning. And we've talked about this before. And this turning is called a rotation. When we spin on our own axis, which is an imaginary line down the center of our planet, we know that this line, we are turning around it. So the rotation of a spinning object. In the image here that we can see, you see a spinning top. So when we spin a top, as it's rotating around its center, its axis, it's doing exactly the same thing as the Earth is doing, the Sun is doing, and the Moon is doing. So all planets and celestial bodies are usually rotating around themselves. Okay? Now, all the planets in our solar system rotate around an axis in the center of it. And on top of that, they orbit around the Sun. So these are two different things, rotation and orbit. Now the Earth turns around its axis once every 24 hours. The Moon takes an entire month for it to completely turn around. Is that crazy? I think it's pretty crazy when you think about it. So a day on a different planet is a different amount of time. Now, when we talk about rotation, we're talking about circling ourselves, spinning around our own axis. When we talk about revolution, we are talking about going around something else. So an orbit and a revolution are the same. So when we have a revolution around the sun, when the Earth goes around the sun, it's 1 year. Okay, that's our orbit, our revolution around the sun. So the moon goes around the Earth in about a month. So the Earth and the moon are traveling together, and they together are going around the sun. So a year for the moon is the same as a year for the Earth. But a day for the moon, because it's turning around itself, is different than a day for Earth. A day for Earth is about 24 hours, and a day for a moon is about a month. Okay? Because of this, the same side of the moon is always facing the Earth. That's why in the Transformer movie, they talk about the dark side of the moon and the fact that they built that base or had the crash landing. And then in Men in Black, they have like the prison on the dark side of the moon. It's because on Earth, we never see the dark side of the moon. Even though it does get sun and light, we never see it. And so there's all these things that people can do in books and movies about the dark side of the moon because it's never actually facing the Earth. Okay. So let's talk about how this whole thing works. Now we know that the Earth has an axis and we're always kind of tilted. And we learned that in our vocabulary words, that the Earth is tilted at a 23.4 degree axis. Okay? Now this axis goes around the sun. Now a lot of people say, okay, why is our axis moving? Well, actually, our axis doesn't move. As we go around the sun, our axis stays the same. And as our axis stays the same around the sun, because we're in different places in our orbit, different sides of us face the sun in a different way of the axis. I know it sounds really confusing, but we're going to do some labs and I'm going to model it for you. And Mrs. Blair and I are going to try and explain it to you in a better way. But as it goes around, the axis never is at the same angle. It's just that we are in different places in the orbit around the sun. Okay, day and night are caused by a rotation on the axis, right? So, Earth is turning. And as we're turning towards the sun, we are facing different ways. So these yellow arrows that you see in the picture here is sunlight aiming towards the Earth, and you see it hitting the Earth and you see it hitting the moon, right? And we're orbiting and the moon is orbiting, and as this is happening, our day is passing. And so as we pass for the 12 hours of the day that we're in the sun, then the 12 hours that we're in the night. And depending on where our axis is and where we are in the orbit, right, the way that we are tilting or facing the sun, where we are in the orbit around the sun depends on how many hours are day or how many hours are night. Okay? If we weren't at an axis, it would be 12 hours and 12 hours. But because it changes, because of where we are in the orbit, then we have a different amount of daylight in the winter and a different amount of daylight in the summer. Okay? Now let's talk about the moon. When we see the moon at this time, what we're seeing is light that is reflecting from the sun. So remember that. This light that's reflecting from the sun onto us looks different at different times of a month. So just like Earth, half of the moon is always hitting the sun. Half the moon always sees the sun. But from Earth, we can only see it some of the time. When we see a full moon, we see all the side of the moon that the sun is hitting. When we have a first quarter or a third quarter moon, we only see a quarter or half of the moon that is lit by the sun. And all the other phases, the waxing and the waning of the sun on the moon, is all due to where Earth and the moon are in position to each other at that point of the month. Because it takes the moon a month, about 27.3 days, for the moon to go around the Earth. And so it takes about a month to go from the full moon to a full moon again. I know this sounds really complicated, but you've been looking at the moon since you were a little person. One thing that people always seem to get confused about are seasons. For some reason, people have got it in their head that seasons are how close and how far away from the sun you are. That has nothing to do with the seasons. Nothing to do with the seasons at all. Because at a certain point in the orbit around the sun, we're kind of closer to the sun, and then we're kind of farther from the sun, and then we get closer again. That has nothing to do with the seasons. Whatever side of the earth is tilted towards the sun is the one that has summer. So when the northern hemisphere of the earth is tilted towards the sun, it is summer for them and winter for the northern part of the earth. When we're in a different part of the orbit around the earth and the southern part of the earth is towards the sun, then that's their summer and our winter. That's why in the wintertime when we have Christmas and Santa comes in his thick coats for us and he's all warm and cozy, he's probably dying of heat stroke in South America because it's just too hot for him. Okay? All right. So here we go. Let's look at the axis in this image. Let's look at winter. North Pole tipped away from the sun. So as we go in our orbit, you will see in the spring it's starting to shift. When we get finally to the summer months for the North Pole, we're tipped here towards the sun. And then as we get into fall, we start to tip away from the sun, and the northern hemisphere is the furthest away during the winter. This has to do with the orbit. Remember, the axis does not move. We do not shift our tilt. We are always tilt the same way. Eclipses. Now, there are two kinds of eclipses. There is a solar eclipse and there's a lunar eclipse. Now, the solar eclipse is when the moon gets in between the earth and the sun. And the moon blocks the sun from certain places on earth. Now, you'll all remember a couple of years ago when we had a solar eclipse. It was right before school started. It ended up being a really cloudy, foggy day in Hayward, and so I'm sure none of you got to see it. But if you were lucky enough to get to see it someplace, you noticed that you couldn't see the solar eclipse everywhere on Earth. You could only see it in certain places, and they actually plot out and tell you where you can be so you can see the solar eclipse. A lunar eclipse, everybody gets to see it, and it actually happens much more frequently. A lunar eclipse is when the moon moves into the shadow of the earth, and the earth blocks all the light from hitting the moon so that the moon is completely dark. Now, when this happens, usually the moon is kind of still visible, and you can kind of see a red tint to it. Now, we're going to learn about waves near the end of the year, but red wavelengths are one of the longest ones in color. And what happens is those waves actually go around the planet Earth and they still bounce off the moon. And so in a way, the moon in a lunar eclipse is still getting a little bit of light from the sun, but not nearly as much as it does when there's a full moon. Okay. So here we can see the drawings again. So here's the solar eclipse, and you can see the Earth, and the moon is here. You'll see that in this area here, it completely blocks out the sun, and in these areas around it, it's partially blocked out, but in the rest of the Earth, the sun looks completely normal. And then here on the bottom, sorry guys, you can't really see because of my silly picture. Let me try and close it out. There. You can see that the moon is behind the earth and most of everything is blocked from the sun except for maybe a few little red rays here and there. Okay? All right. So, where did I go? All right, now, can I come back?